All right, in this video, we're going to look at two more methods for solving quadratic equations. We're going to look at completing the square and using the quadratic formula. Completing the square is my personal method of choice whenever it is easy to apply, and we'll talk about when it is easy. To me, this is much faster and much simpler than using the quadratic formula. So this is the one that you will see me modeling the most in class this year, because anytime I can complete the square, this is what I'm going to do. So the idea is that if you have a binomial in the form of x squared plus bx, then if you take half of b and square it, you will create a perfect square trinomial. Now think about why that is. If I know, remember when we get a perfect square, the rule is square the first, square the last, multiply, and double. So we get 2ab like this. If I know that this first one is x squared plus 2 times x times we don't know what, plus we don't know what squared, I know that the x came from this term. So if I can take out the x, and then if I take half of this, why would I take half? Well, because I want to undo the double part. I'm just going to be left with what the thing is supposed to be squared. I'm going to be left with what my last is. And so what we're doing is creating a perfect square. If we create a perfect square like this, this is something that we can then apply the square root process to and solve that way. Now, you can see the downfall in this. Because we need to divide by 2, it's not a very friendly method if b is an odd number. Like if I had x squared plus 5x, that's not going to be great. So I won't use it in that case. But if b is an even number and if a is 1, because again, if this is something other than x, then this rule here in the middle kind of breaks down. So the two things that you're looking for when you want to use completing the square is that you have a 1, not a 1x squared, and you want a bx where b is even. That's kind of your clues for when completing the square is going to be your most efficient method. Okay, so what we're going to do, and I'll show you how I kind of set up my problems each time, is we always need to get the x squared plus bx part by itself. So in this case, I have x squared minus 6x. That plus 4 is in my way, so I'm going to subtract it to the other side. But notice I'm going to leave myself some space here. So this equals negative 4. Now, what I'm going to do is I'm going to take half of b and square it, and I'm going to add that right here to make a perfect square. However, if I add something to one side of my equation, I must also add it to the other side of my equation. All right, so now we look at b, which right here is negative 6. Now I'm going to square it, so it doesn't matter whether it's negative or positive. It's going to always come out positive. And I usually do this piece in my head, but I'm going to write it out for you so you can see where it's coming from this time. We're going to take 6 divided by 2, and then we're going to square it. And that's what we're going to add in the blank on both sides. Well, 6 divided by 2 is 3, and 3 squared is 9. So we get x squared minus 6x plus 9 equals negative 4 plus 9. I usually skip straight to here. I'll do that orange piece kind of in my head, but that shows you where it comes from. Now, why did we do that? Because this, by design, is a perfect square. So this should factor to x minus 3 squared, and negative 4 plus 9 gives me 5. Now this looks like the square root problems that we did yesterday. So we can take the square root of both sides, and we now have x minus 3 equals plus or minus the square root of 5. So add 3 to both sides, and x equals 3 plus or minus the square root of 5. That's a perfectly fine answer for me written out. Math lab is going to be looking for 3 minus the square root of 5 and 3 plus the square root of 5. That would be our solution set. Okay, so again, we need to get x squared plus bx by itself and then set up our blanks on both sides of the equation. So I'd like for you to pause the video and try number 18. I'll come back in 3 seconds. All right, so it's already set up for us. We have it split the way we want. Now we need to decide what goes on both sides. So I'm going to take half of 4, which is 2, and then 2 squared, which is also 4. And if I add it to one side, I'm going to add it to the other. Now we're ready to factor this. It's going to be x plus 2 squared equals 5. Take the square root of both sides. So x plus 2 is equal to plus or minus the square root of 5. And so x is equal to negative 2 plus or minus the square root of 5. And again, if it's math lab, you can write it out as a set. But for me, that answer is just fine. Okay, so that is how we complete the square. If b is an odd number, then you're going to be taking a fraction and squaring it, which isn't hard, but it just makes it a little bit more work. It's not as fast. And so if it doesn't fit the criteria for completing the square, then we can go to the quadratic formula. Quadratic formula is like Old Faithful. It is always going to work. Hopefully you already have the quadratic formula memorized. If not, put it on a flashcard. That is something that you need to have memorized. Go on YouTube. There's like 50 different songs you can memorize to help you learn the quadratic formula. So the quadratic formula is this. If our quadratic is in standard form, or general form as our book calls it, which again means that it's all set to 0, then x is always going to be equal to the opposite of b plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. So let's use the quadratic formula. For me, I hate the quadratic formula. It's so much work. If I can come up with any other strategy, I'm going to do that rather than use the quadratic formula. But it does work every time. It is up to you. So in this case, if we look at number 19, a is equal to 2, b is equal to negative 6, and c is equal to 1. Okay, so we just want to plug everything into our formula then. X is equal to the opposite of b. Well, b is negative 6, so the opposite is going to be positive 6, plus or minus the square root of negative 6 squared minus 4 times 2 times 1. That's a times c, and that's all over, including the 6 plus or minus, all over 2a, which is 2. Again, I don't want decimals. We always want the exact value unless it tells us to round, and it is not going to. So let's work on simplifying. We have 6 plus or minus the square root of, that's going to be 36 minus 8, so this is going to be the square root of 28, all over 4. Now we need to see if we can simplify the square root of 28, and we can because 28 is 4 times 7, and 4 is a perfect square. So we have 6 plus or minus, the square root of 4 is 2, so now we can bring it out, and 7 was not perfect, so we leave it inside, and that is 4. Now, when you simplify this, the only way that you can divide is if you can divide all 3 things, because it has to be a factor of all 3 parts. And so in this case, 6, 2, and 4, I can divide them all by 2, so I get 3 plus or minus 1 root 7 over 2. Now again, that's a perfectly acceptable answer for me. My math lab might want you to break it apart as 3 over 2 plus or minus, the square root of 7 over 2. I'm not 100% sure. I would try putting it in this way. And you might have to write it out twice using a set. 3 plus the square root of 7 over 2, 3 minus the square root of 7 over 2. Okay. Number 20 is going to be the same, but before we can start, we have to get this equal to 0. So 2x squared plus 2x minus 1 equals 0. And now you can use the quadratic formula. So pause your video and give this one a whirl on your own. All right, here's the answer that I get. Again, you can only simplify if you can divide all 3 parts by the same number, and here we can. Also notice that this turned to plus 8 because we had negative 4 times 2 times negative 1, so that becomes a positive. And then 12, the square root of 12, simplifies down to 2 root 3. So those are our answers. Now, the last thing that we can sometimes use the quadratic formula for is looking at what we call the discriminant. The discriminant is just the b squared minus 4ac part of the quadratic formula. That's the part that's underneath the square root. Okay, now if we think about what we have when we do a square root, in this case, b squared minus 4ac is greater than 0. That would mean we're doing the square root of a positive number. Well, that we can do. And since it's going to be plus or minus, you're going to get 2 unique real number solutions, meaning not imaginary. So you might get like 2 plus the square root of 3, 2 minus the square root of 3. That's 2 unequal real solutions. If b squared minus 4ac is equal to 0, that means we're doing plus or minus the square root of 0. Well, plus or minus 0 is still just 0. So you only get one solution if that is the case. And if you get plus or minus the square root of a negative number, well, we can't square root a negative and get a real number. So you end up with no real solutions. And what we know happens there is that instead we get 2 imaginary solutions. And we're not going to be looking at imaginaries just quite yet. So no real solutions is going to be the answer that you are looking for. Okay, so in these examples below, it says compute the discriminant. That means do b squared minus 4ac and see what number you get. And then based on that value, following these 3 rules, what does that mean? So let's do the first one. B squared, that's going to be negative 8 squared minus 4 times 1. That's 4ac. So we get 64 minus 16, that is 48. So that's the value of the discriminant. Well, what do we know about 48? 48 is greater than 0, which means we have 2 real solutions. That's the top row in the table there, okay? Pause the video and try number 22 to finish up this section. Okay, b squared minus 4ac in this case is going to be negative 2 squared minus 4 times 3 times 5. Well, we get 4 minus 60, which gives us negative 56. That is less than 0, so this one has no real solutions. That's how you can use the discriminant to make some decisions there about the types of solutions that we want. Discriminant is a word you need to recognize. That needs to go on a flashcard. That's vocabulary that when you see that on the test, a lot of times if we don't study those, we're not going to remember what that's asking. That happened on our last test with the words decompose. We forgot to study that part and we didn't know what the question was asking us there. So put that on a flashcard, start studying discriminant, and that takes us through solving quadratic equations.